We're going to talk about time clocks today. We're working on a Texas multi-zone, and the Texas multi-zone has a large fan. The large fan is controlled by the handoff auto switch, and the schedule is controlled by this old time clock. So you need to know, since we're putting building automation on it, we need to bypass this time clock. We don't want the time clock having any control anymore. The scheduling will all come from the building automation system. And so we need to know about time clocks. So the time clock has 120 volt to run the clock motor, to keep time. So you can see coming in on A and coming in on B, you have 120 volt. Now we don't know which one is hot and which one's neutral. So, but just looking at it down below, white is on A, and then down that third screw, or the middle screw on the bottom, that's B. And so the black ought to be 120 and the white ought to be neutral, and so I've confirmed that with my meter. I went between white and a good ground like this conduit, and you get 0 volts. And I went between that middle screw with the black and the red and ground, and I got 120. So 120 hot comes in on that middle screw, and it gets also jumped over to the screw just to the right of it, which is terminal 7. So B is your 120 hot, terminal 7 is your common of the switching side, and then terminal 8 is the normally open terminal. It's normally open with number 7. You can see this little arrow, and you see how it's not touching. So I've got yellow on number 8. I've got yellow on a twist timer, which acts as a bypass. So the twist timer, come to find out after tugging on these wires, one wire goes to the power source. The other wire, the yellow wire, ties in with yellow that goes to the auto function on the handoff auto. So the auto function is here on that terminal. The hand function is there on that terminal, the black wire. Well, so the purpose is I'm going to put a relay controlled by the building automation, and the relay is going to be on this top hole, and the relay needs to break the auto circuit from the handoff auto. You don't want to break the hand circuit. That's wrong. You want the hand circuit to still function. So anytime you put a relay on a handoff auto, you want to be sure that the relay breaks the auto circuit. So I set out to find out where my auto circuit came from, which one it was. I could kill power and check things with my meter and figure out which, for sure, that was the auto terminal. A lot of times you also have a diagram on the inside of the panel of the handoff auto, so you can check that diagram and figure things out that way. So this time clock is just breaking power to this yellow wire. So, I've also got this control switch, and if I turn the control switch off, the time clock does nothing, which means that this is upstream. The power comes in from the left, it goes straight here, and then from here to the time clock. From the time clock it goes down to the timer, the bypass timer, and the handoff auto. I'm going to do away with the bypass timer. I'm going to do away with this time clock, and I'm going to leave this in place just as a sort of like a disconnect. So in order to bypass this time clock, I'm just going to take the wires from terminal 8 and tie them in with the wires from terminal 7. I also see a temperature safety. This entire room is full of return air, and so I suppose if there was a fire, this could act as a safety that would kill the fan. So I'm going to leave that in. I'm going to leave that in the circuit. Another interesting thing about these old time clocks, this is how they set the schedule. You can loosen these screws and slide these around, and it corresponds to a time. And so as these pass the catch, it'll turn the contacts either on or off.